All right, so we're talking about complex numbers today. So we're going to talk about a plus the bi form. There's two parts of this. There is that part right there, which is the real part, which is a real number. So you've dealt with real numbers all semester, and real numbers are like whole numbers, integers, fractions, rational numbers. Those are all real numbers. And then you have also this part over here, which this part is the imaginary part. So anytime you see this I, and you notice my I has a little tail to it, and the dot is a little bit bigger because in the past what happens is that I might see a 8I and they'll draw a regular I with a dot and you can't see the dot, so it looks like an 81 instead of an 8I. So I would suggest that you put a little tail to that. And this imaginary part is not a real number. So in the past, you have seen something like they tell you to simplify square root of negative 25, and you ended up with saying it's not a real number, and that's why that's the case. So now that we have the I, we can actually simplify square root of negative 25. All right. So what the heck is I? So what is I? Okay. So that's the question. So I has the value of the square root of negative 1. Okay. So if we think about this, if we were to square both sides, the left side would just be I squared. However, the right side, if I square the right side, the square and the square root would cancel each other out, leaving me with just the negative 1. Okay, so these are the two pieces of information that's kind of important to you to remember as we move along. Okay, so let's do some examples. So example 1, we just talked about the square root of negative 25. Okay, before we just said it was not a real number. Okay, and then we would be done. However, now that we're learning about i's, we are able to simplify this. So what we can do is break down the square root of 25 to negative 1. So anytime you have a negative underneath a square root, you want to pull out that negative 1. Okay, and then break down the 25, which I've always taught to break it down as primes. And we know that the index is the 2. So we're looking for pairs. So here's my pair. All right. And so essentially what we have here is the square root of negative 1 times 5, because that's the pair that can come out to play. So we have I times 5. And we wouldn't write it as I5, just like if it was an X, we wouldn't write it as X5. We would write it as a 5I. Now that's just a regular answer. Okay. In this section, most of the time they're going to ask for the A plus BI form. Okay, so since the 5 is attached to the I, that is my imaginary part, which is fine. But I don't have the real part. So if I don't have a real part, then that must be just 0. So this is my A plus BI form. Okay, so those are my possible answers there. Let me do this really quick. Put that over here so that I can box that together. All right. All right. So now another example is that let's say that I got an answer of just 2. Okay, so 2 would be my real part, and I want to change that to an a plus bi form. So there's no imaginary part, there's just a real part 2. And since there's no imaginary part, that would be a 0i. So that would be my a plus bi form. Okay. All right. So we're going to talk about all the operations. So let's talk about addition and subtraction of complex numbers. Okay. So with addition and subtraction, it's going to be like polynomials and radicals, where we need like terms. Okay, so let's do a simple problem. Let's say it's 5 plus 4i minus a 9 minus 8i. So what I have to do is get rid of the parentheses first. So the first part is not a big deal. I have 5 plus 4i. But the second part, this negative has to be distributed. So I have a negative 9 plus 8i. All right. One of the things that you might want to think about, because if the i's were x's, like polynomials, then we would add these together and add these together, and that's what we would do. So something to think about is maybe when you have these type of problems is to stack them. So if I stack them, it'll look something like this. All right, so then I can just add it this way, straight up and down. So what we have is negative 4 plus 12i. Okay, and that's already an a plus bi form, so that's great. That's what I would love to happen every single time. All right, so let's talk about another example. So we're at example 4. Okay, so let's do something a little more complicated. That's kind of what we've been seeing, but with square root of negative numbers. So let's say square root of negative 75 plus the square root of negative 27. All right, so let's break these down. But before I do that, let's make this red, and then let's make this blue. Okay, so square root of negative 75 would break down to square root of negative 1 times 3 times 5 times 5. Okay, breaking it down to primes, plus the square root of negative 1 times 3 times 3 times 3. Okay, so I know that the index is a 2. So we're looking for pairs. So here's a pair, and here is a pair. Okay, and then this lonely 3 and this lonely 3 has to stay inside the house to play inside the house. So what do we have? We have the square root of negative 1. We have the 5 that comes out, and then we have the square root of 3 that stays in, plus square root of negative 1, the 3 that comes out, and the 3 that stays in. So let me do this here. So this is the 3 that was staying inside. So you see the color matches there. This is the 5 that came out, and this is the 3 that came out. Okay, so you see where those numbers came from. So now what do I have? Now I have an I times a 5 times square root of 3 plus I times 3 times square root of 3. Okay, so let's reorder this the right way. So this should be a 5i square root of 3 plus 3i square root of 3. All right, So when we're combining like terms, like I said before, it's like polynomials and radicals, okay? In order for us to add these two, we have to not just look at the radicals being the same. So if one was square root of 3 and one square root of 2, we can't combine these two. But since they're both square root of 3, we can. Better yet, the I here also has to be the same. So if one was I and one was I squared, we wouldn't be able to combine them either. So we have to make sure that the I is the same and the radical is the same. So since they are the same, then what we have here is a 8I square root of 3, okay? So how do I write this as an a plus bi form, okay? So this is clearly the imaginary part because the I is attached to it, so I don't have a real part, okay? So I would have to do it as 0, because that's the real part, plus, watch this, 8 square root of 3I, okay? So that would be my a plus bi form. So that's why I gotta be careful with, okay? And make sure you put a little space after the radical so that the I doesn't look like it's under the radical. Okie dokie. All right. All right, let's go to the next example. So next thing we're gonna talk about is multiplying. Complex numbers. Okay, it has the same ideas as we were going. So I want to take the same two square root negative numbers, and instead of adding them, I'm going to multiply them. All right, so we have the square root. So this is example 5. So I got the square root of negative 75 times the square root of negative 27. All right. So if I was to break this down, same thing as a breakdown under up top. Let me do this here. Change this to red. Oh, that doesn't work. Change this to red. Change this to blue. And this breaks down to the square root of negative 1 times 3 times 5 times 5 times the square root of negative 1 times 3 times 3 times 3. Okay? And what we broke these down to was a 5I square root of 3 times 3I square root of 3. So if you're wondering how I broke those down, the explanation is right up here on example 4. Okay, so when I'm multiplying here, what I gotta know is, you know, when we talked about multiplying with radicals, you can only multiply if you're both outside. You can multiply if you're both inside, but not when one of them is outside and one of them is inside. So I can multiply the 5 and the 3 here because they're both outside. I would have to multiply the I and the I. And I would multiply the radical with the radical because they're both the same index. Okay, so what do I have here? I'm going to have 15I squared times, and square root of 3 times square root of 3 is just 3. So what I actually have here is a 45I squared. Okay, so question is, what in the world, I'll leave it as this, is I squared, okay? And we talked about up here, way in the beginning, that I squared is actually equal to negative 1, okay? So, let's come back down here. So, I squared is actually equal to negative 1. So, I actually have 45 times a negative 1, so this is just going to equal to 45. So notice something, that if I have two i's multiplied together, two imaginary parts multiplied together, I actually get a real part out. So it's almost like 2 wrong makes a right. So now if I was to put in a plus bi form, this would be the real part is 45, because there's no I attached to it. And then since there's no imaginary part, it'll be 0i. So that would be my a plus bi form. And there's my answer. Okie dokie. So let's look at something else that you're going to be multiplying that would be under complex. So example 6. So let's look at something that you're familiar with, but we tend to get wrong quite a bit because we mix up the rules a little bit. Now, since this is a binomial squared, that means I have to write this out twice. And multiply. Well, in order to multiply these two, I need to either FOIL or double distribute. Now, I would tell you that I would prefer to double distribute. Why? Because it's easier to see everything, especially with radicals and with complex numbers. Okay, so if I double distribute, it's going to look something like this. It's going to look like 8 times the 8 minus 9i, negative 9i times 8 minus 9i. So that's double distribute. So what am I going to get? I got 8 times 8, that's 64. I have 8 times negative 9, that gives you negative 72i. I'm going to have negative 9 times 8, which is negative 72i. And then I have negative 9i times negative 9i, which gives me positive 81i squared. All right? So, again, what is this? This is actually 81 times negative 1, which becomes a minus 81. Okay, so here are my like terms. These are my real parts, and these are my imaginary parts. All right, so what I'll actually have is negative 17 minus 144i. So it's just like multiplying by x's. We keep the x and add the coefficients. So this came from those two numbers there, and this came from those numbers there. Okay, so that was example 6. All right, so let's skip into dividing. Okay, so you might have something like 5 divided by I. Okay, so with radicals, we knew that we can't have radicals in the denominator, and that's why you learned how to rationalize the denominator. However, remember that I is actually the square root of negative 1, so it's actually a radical. So that means since radicals can't be in the denominator, that means the i's cannot be in the denominator as well. Now, if the denominator is a monomial, it's really easy. Because what will we multiply I by to get rid of the I? Well, I squared is negative 1, so if I multiply I by another I, then I'll get negative 1. So I'm going to get 5i over negative 1. And since I can't have a negative denominator, this is just going to be a negative 5i, or it's going to be 0 minus 5i. And that would be my a plus bi form. Okie doke. Not too shabby. All right. So let's do, again, with monomials, it's pretty simple overall. Because like even if it was, let's say 2 over 3i, all we have to do is multiply. The 3 is allowed to be in the denominator, so we don't need to mess around with the 3. So we just need to multiply by the I. Okay, so we're going to get 2I over 3I squared, which is 2I over 3 times negative 1 is negative 3. So we have a negative 2I over 3. Or in A plus BI form, again, no real part, minus 2/3 I. A plus BI. So this is the 2/3 I is almost like when we were looking for slope after solving for y and y equals mx plus b. So we wouldn't say 2x over 3, we would say 2/3 x as the mx part of the y equals mx plus b, okay? Here we go. All right. But what if the denominator was a binomial? All right, so I lost track of the examples here. This example 7, example 8. So we're down to example 9. So what if it was a binomial? So let's say I got 7 minus I over 2 minus 4I. First of all, these are binomials. So put some parentheses around it. Now, the mistake that people make is that they mix up if the denominator is a monomial versus a binomial, okay? So what they will tend to do is they say, well, let me just multiply top and bottom by I. Well, if you look at the bottom, you actually get 2I plus 4. But the issue is that the I is still there in the denominator, so that will not work, okay? So we can't multiply by I. However, like the radicals, we actually multiplied by the conjugate of that denominator, okay? So I told you guys that double distributing would be the best way to go. So that's what I'm gonna do. I'm gonna show you double distributing. So I got a 7 times a 2 plus 4I minus I times the 2 plus 4I. And the bottom is going to be the 2 times 2. Let's try that again. That's the right color. 2 plus 4I minus 4I times 2 plus 4I. Okay? So let's look at what the top gives me. All right? The top is going to give me 14 plus 28I minus 2I minus 4I squared over 4 plus 8I minus 8I minus 16I squared. Okay? So we're looking at this again. And what does this give me? This is going to be negative 4 times a negative 1. So this is going to be a plus 4. All right? And this down here is going to give me negative 16 times a negative 1, which would be a plus 16. Okay? So we got to remember that as we're combining like terms. So what do we have on top? The top, we're going to have a 14 plus 4, so it gives me 18 plus a 26I. And the denominator, look at what happens with the I. Look at what happens with the I. I got positive and negative, so they cancel each other out. So all I'm left with on the bottom is a 4 plus 16, which gives me 20. okay? So if you notice that the top I foiled or double distributed, great. But the bottom, since they're conjugates, I don't have to foil because my oi goes away. So the bottom, all I really need to do is fl, which means first and last. I don't need to do the oi, the outer and inner, because they cancel each other out. Okay, so just the fl on the bottom because they're conjugates. All right. So now from here, I can simplify this. So I'm going to talk about this triangle method. The triangle method says that if the coefficient of these three here are outside the house and something can go into all three, then we can reduce this. So what goes into 18, 26, and 20? 2 does, correct. So we're going to do 9 plus 13i over 10. This is not the a plus bi form. The a plus bi form would be 9 over 10, so we got to split up this fraction, plus 13 over 10i, okay? So again, it all depends on what the directions give us to give them. If it's a plus bi form, then that's what I want to do, so that's what I would do, okay? So over here, this is the a plus bi form, all right? Now, when you split this up and any of the two fractions can reduce more, I would tell you to go ahead and reduce more, okay? So that's the biggest part for me. Now, you could have done this no matter what. You could have said, okay, you know what? I'm going to go directly to splitting this fraction. So you could have said, okay, this is what I'm going to do. I'm going to come down here, and I'm going to split this fraction right off the bat. So I got 18 over 20 plus 26 over 20i, because they're going to want this a plus bi form. So why, screw with it. So what you can do then is say, okay, what goes into 18 and 20? And you'll say 2. So you go, okay, so this is equal to 9 over 10, okay, plus, and then you go, what goes into 26 and 20? You say 2 as well. So this is going to give you a 13 over 10i. So you can do it that way as well. It's probably a way that you might want to think about doing, just so that it becomes a little bit easier, because if it's going to ask for a plus bi form anyways, this might be an easier way to do it. All right. Hope you enjoy it, and I'll see you next time.